Welcome to my YouTube channel VKS Chem Tutorial. In this channel, I am discussing the important topics from organic chemistry in UG and PG level. You can watch this channel if you are preparing for CSIR NET GATE examinations also. In this video, I will discuss some important questions and answers of Norrish Type I reactions of cyclic ketone. Okay, let us take the first question. This is the first question. Norrish Type I reactions of cyclic ketone involves primarily the alpha cleavage of C double bond O, C double bond O, C bond. It is the alpha CO C bond of ketone followed by some secondary reaction as decarbonylation and abstraction of hydrogen, etc. You can see the mechanism of this reaction. First, this alpha cleavage takes place to form a biradical, and this biradical decarbonylate forming another biradical, and in the secondary reaction. Okay, this biradical may abstract a hydrogen from this position. Here is a hydrogen atom, the bond cleaved homolytically, and hydrogen radical will be abstracted by this radical, forming a double bond in this position. There will be a double bond in this position because of abstraction of hydrogen from this carbon atom to this carbon atom. Thereby we will get this alkene. This alkene is formed by this secondary reaction. Another possibility is the ring closure from this biradical, whereby you will get these two compounds. One is trans, it is trans variety, and it is cis variety. Cis dimethyl cyclopentane and trans dimethyl cyclopentane are obtained. So, by this reaction, photochemical reaction of this dimethyl cyclohexanone, we will get these three products. One acyclic alkene along with cycloalkanes, that is trans dimethyl cyclopentane and cis dimethyl cyclopentane. Okay, now see the second question. Photolysis of norbornanone. First it undergo the alpha cleavage in this position and also from this position, whereby these two biradicals are formed. These biradicals then undergone decarbonylation, forming this biradical. There is every possibility for ring closure between these radicals. There will be a bond formation between these radicals, forming this cyclic product. Now consider the third example, the photolysis of this molecule. You can see, first of all, the alpha cleavage takes place to form this biradical, and from this biradical, decarbonylation takes place, forming this biradical after eliminating carbon monoxide, and there is chance for ring closure reaction here, thereby a bicyclic molecule like this is formed, and also there is a chance for formation of pi bond on either side by sharing the electrons pi bond to this carbon atom. Thereby we will get this alkene. Here is a double bond. Here also a double bond is formed by sharing this pi electron between this carbon atom. Thereby two double bonds or pi bonds are formed here, thereby forming these compounds. And so by the photolysis of this molecule, we will get these two products, one bicyclic compound and the other is this unsaturated diene. Then take the next example, and in this example also, first of all, alpha cleavage takes place by the photolysis, forming this biradical, and again, as in the previous case, the decarbonylation takes place, forming this biradical, and then you can see here is a double bond, a pi bond is here, and photolysis of this pi bond share the electrons of pi bond to this carbon atom and also to this carbon atom, thereby form a double bond formation between this carbon and oxygen. You can see here is carbonyl group is formed between this carbon and oxygen by sharing these electrons of oxygen, the odd electron of oxygen and the odd electron of carbon atom. Thereby a carbonyl group is formed here. Then in this biradical there is a possibility of ring closure. After ring closing you will get a cyclopropanone derivative by this photolysis of this compound. Okay. Then take the fifth example. In this example also, on photolysis, first of all the alpha bond cleavage takes place to form this biradical, and there is every chance for a ring closure reaction forming this molecule, but it is the original molecule with configuration getting inverted. Here it is trans, but after ring closure we will get the cis isomer. Then there is a chance for hydrogen abstraction from this carbon atom, that is alpha carbon atom, to this carbon atom. Thereby this bond becomes unsaturated. This carbonyl carbon and the carbon bond becomes unsaturated by the absorption of this hydrogen radical by this carbon atom, and so a ketene is formed. Here a ketene, this molecule is a ketene is formed, and then because we are using alcohol as solvent in this reaction, alcohol added to this ketene molecule to form an ester as the end product. Okay, now take the last example, this example. As in the previous case, the alpha cleavage followed by the elimination of carbon monoxide leads to the formation of this biradical, and this biradical again on photolysis of this bond, thereby an electron goes to that carbon atom, another electron goes to this carbon atom, and there is possibility for the formation of a diene by sharing these two electrons between these two carbon atoms, and these two electrons between these two carbon atoms. So we will get an open chain diene as the product. You can see the product. It is the final product. Okay. So we have already discussed all these problems and their answers. Here I conclude my video. Thank you.